Okay, sorry for the little delay right there. We're going to finish up the notes from section 8.3 that we did the other day, and we're going to do the special cases. So I have 3 different examples, so these are going to be fairly short notes that we're going to talk about. One of the examples we actually did earlier, and that would be something similar to this. We're going to go back to talk about multiplying binomials here. And if you look at these 2 binomials, you'll see something similar about them, and that they look exactly the same, except for one has a plus sign, the other one has a minus sign. And anytime you have that, something special happens every time you have binomials like that. So if we go through and actually just distribute, so x times x is x squared, x times negative 3 is negative 3x, 3 times x is 3x, and 3 times negative 3 is negative 9. And what you'll notice every time, whenever you have binomials that are almost identical, but one is minus and one is plus, is that these inside terms cancel out every single time. And eventually, when we talk about factoring, that's a situation that comes up and actually has a special name to it. Now, another case that I would like to talk about is something like this. Okay, so the way you would say that is the quantity of 2x plus 5 squared. Now, what does the exponent of 2 mean? Well, it means that we have 2 of whatever is below it. So in this case, we have 2 of these binomials. So what you need to do is this. You need to rewrite it twice. Okay, so this is kind of just a shortcut way of writing this. And then you just go back to your foiling or your distributing twice. So 2x times 2x is 4x squared. 2x times 5 is 10x. 5 times 2x is 10x also. And 5 times 5 is 25. So simplify. 4x squared plus 20x plus 25. There you go. Big thing that you want to avoid in this one, and this is a pretty common mistake, is people try and distribute that 2 in here. But that is not the case. If you remember our exponent rules, when we distributed our exponent into parentheses, it was always multiplication everywhere. But because of that addition sign, you cannot do that. Okay, last one that I would like to do. As I said, fairly short notes today. What if I have multiple variables in there? Slide this over just a little bit. Well, multiple variables don't change what we do, it just changes what our answer is going to look like. So if I were to follow the same idea as what we did right there, I'm going to multiply this times itself. So I have to write it twice. And then we're going to go through and do a bunch of multiplying again. So if I distribute, 3x squared times 3x squared is 9x to the 4th. We were adding those exponents right there. Now 3x squared times 5y. So I can multiply the 3 and the 5 to get 15, and then the x squared, and then the y. And then now let's just do this. So 5y times 3x squared is again 15x squared y. And 5y times 5y is 25y squared. So the process isn't any different right there. It's just that we have multiple variables. We have x's and y's. So let's do some combining like terms. Nothing goes with the 9x to the 4th. And notice these are the same. They both have x squared y. So we can combine those. 30x squared y. And then 25y squared. Now you might be thinking, well, I can combine these. They both have y's. But remember, in order for them to be like terms, the variables have to be identical and the exponents have to be the same. So while these both have y's, this has a y squared and this only has a y. Plus it has an x squared also. So that's it. That's as fine as far as we can go. Alright, hopefully that worked. And if you have any questions, make sure you bring the questions to class tomorrow.